Hi everyone, Gary Norton here. I wanted to take a couple minutes and show you something today that honestly I've had a hard time explaining to people, and it really is about the generative nature of AI when it comes to LLMs. Sometimes it's hard to think that they're not concrete on the answers they give, but in essence they predict from word to word how the conversation's going to evolve. Every word or token, more specifically, has a percentage or likelihood of being assigned to a conversation. There's an outdated tool that illustrates this, and although it's deprecated, it's the best way I found to help people understand that. So I wanted to show it to you and even show you the URL just in case you wanted to go out on your own and play with it. But if you go to the playground for the OpenAI API, you'll notice that when you get in here, you're traditionally going to be here on the top, and it will put you under this chat node right here. And you can do a number of settings where you can change the models and everything on the side. But if you actually come down here at the bottom, you'll see a completions tab where if you come in here, you'll see that it actually says that it's now considered legacy. That's okay. We're just testing. The cool thing about this, though, is that the model isn't that outdated. So I want to explain a little bit about the settings that are here on the right-hand side and the implications they have to our testing. Now, I created actually a couple of videos about tokens and what they mean to LLMs. And so if you don't understand tokens, or down here, this maximum length where we start talking about token length in terms of context windows, please go watch those videos. They're actually pretty helpful, and it will at least make the terms I'm talking about not so confusing. Because AI is generative, it has to get a little bit creative. That's what temperature is. This is the creativity meter. And when we set it to 1, it means use normal amounts of creativity. And what does creativity mean to a computer? Well, it just means that when it's given a series of options, it doesn't always choose the most probable option. It might choose something lower on the list, leading to more varied results. Now, if you go over to the end here, at least with OpenAI, all the way up to 2, it gets crazy and the results are nonsensical. I'll even show you that. But for now, we're going to leave it just at standard creativity. The maximum length is maximum length in tokens. That's 2048. You're going to be about, 1,1800 words there. Again, if it doesn't make sense, go watch the tokens video. Top P stands for the top percentages. So when a token is generated, a number of results are given back for what the next thing in line might be. And they go from most probable down to least probable. Top P represents how many of those options do you want to consider. So if it's set to 1, like it is now, it will mean it will consider every option from 100% likelihood all the way down to 0%. Usually we don't want those lower versions. If I were to set this to top P of like 0.5 and it returned 10 results, it would only consider the top 5 values for the next token, and it would just drop that bottom half. So this is pretty good. I usually find, especially when you're bumping up your creativity, you want to keep that top P a little bit lower, because the more creative you get, it means the more likely it's going to not choose that number 1 answer. And if it's not going to choose that number 1 answer, you generally want to protect, because you almost never want it to choose the bottom answer. So that's how that would go in. Now, in order to reduce redundancy in it, you can use these these values here. One's a frequency presence or penalty, and the other's presence penalty. Basically, if you've heard a sentence where people repeat certain words as they talk, that's what this is. Once a word is used, it will get a slight adjustment to its value so that it doesn't get reused again. You've probably heard me in this already repeat certain words multiple times. probably like the word basically or something. I don't know. The result is that some repetition of words is natural, but ultimately it can be a distraction and sound fake if it's done too much. And then the best of is a server-side calculation where we're asking the server, before it comes back to me with the answer, generate X number of responses on the server and give me the best one you can think of. Most of the time, you're going to leave that to 1. And then inject start, inject restart. I'm not going to worry about that here. This setting at the bottom with show probabilities, this is really cool because this is what I wanted to do the video for. When it shows you the text or when it predicts the next word in the text, this is going to show you the list it was choosing from. Whether you want the most likely values, which would be the upper end of this top P, or the least likely, which would be the lower end. We're going to do full spectrum now because I want to give you kind of an idea. So we're not really worried about what AI is telling us about here. I just want to see the likelihood of the words that are coming. So I don't know. Name a common, if I could spell, children's, how did I not spell that right? Wants the apostrophe S. Doesn't matter, even if you misspell, AI gets it right, usually. So I'm going to go ahead and submit this down here. And when we submit it, you're actually going to see that it came back with Twinkle, Twinkle, Little Star. Probably one of the first things that you came in your head. Now, there are some colors here, and the colors actually represent the likelihood or the value of the percentage that it chose. Now, that will make more sense here as I start to hover. So you'll notice that the words TW started here. That's how it wanted to start the sentence. Now remember, AI doesn't deal with words. It deals with tokens, and tokens can be parts of words. Again, go watch those videos if you haven't seen it. The first token that it chose here, well, you can see here, it starts with TW, which in Twinkle Twinkle is half of the word of twinkle. But it also had some other suggestions. One of the options it came back with was Mary. Now, if you're familiar with English and it's your native language, you probably recognize that Mary is most likely Mary had a little lamb. The third option, but it's down at 1.56%, was Jack. Jack be nimble, Jack be quick, I think. Or row, row, row your boat. Or little Bo Peep. Or old something. That's probably Humpty Dumpty. 3, maybe. And see, even though this is 0, I can come up with that. That's probably going to eventually lead me to 3 blind mice. And maybe this is something to do with London bridges. However, you see that TW is 98% likely. So it's almost predictive in the sense that AI is going to choose this most of the time. Now, if I were to change this top P percentage here all the way up to 1, it would be able to consider things all the way, all the way down my list here, if I can get that back. But because I chopped it off at half, it actually wouldn't really consider anything below the word little here. But it did choose TW. Well, what comes after TW? Well, inkle, or the token for the last half of that word, is 100%. I can't really think of what would come after that. Maybe the word two, TWO, something. But in essence, we're going to get twinkle almost every time. Well, what comes after twinkle? The next time we go in, well, it chooses TW again at an 85% likelihood. And then it starts introducing things like a comma. Again, punctuation can be a token. Or you notice here that it has a lowercase TW. Well, what's the difference? You and I know that TW and TW mean the same thing. This is because AI was trained on massive amounts of data. And my guess is in that massive amount of data, it had multiple versions of Twinkle, Twinkle, Little Star. Some of them went twinkle, twinkle, like this option. Some of them went twinkle and then probably followed it with a comma. And some of them probably didn't worry about spelling or grammar and then didn't capitalize this second version. So, okay, well, let's progress. Well, now let's get here to little. Again, it's really predictive because in the amount of data it's trained on, if you have the phrase twinkle, twinkle together, little is almost always going to happen. Well, that's pretty cool. Now, AI, again, is generative in nature. It's not deterministic. Deterministic would mean every time I ask this question, I would get this answer exactly how it is. I wouldn't get any of those versions that had commas or capitalization. So what will happen down here, and I'm going to show you this, is every time I regenerate it, we'll do it a couple times until we can get some different variations. I ran it again, twinkle, twinkle, little star. You can see it's leaning into that heavily deterministic nature. Again, 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 again. It's following these pretty common. And so you might think it's deterministic. And many times when you generate a prompt and you go through this, you think that you're always going to get the same answer. Now, this is a problem in workflow analysis because you get an answer like this a few times and you start thinking that's going to be predictive. And all of a sudden, one time it breaks and you don't know why. That's why, particularly with workflows in output formatting, you want to adhere a standard. Well, let's take this back up to a top P, and let's tell this to get a little more creative here. We'll go all the way up to 1.8, and we'll start seeing what else we can get. Let's regenerate. Boom, first event. Now all of a sudden we're at a deterministic nature in the Humpty Dumpty. Now, I'm colorblind, so I don't see it that well, but I do see well enough to see that that H there is a different color than the greens you were seeing. And what that means in this tool is that it shows something lower than the highest probability. So if I click on it, you can see it shows number 2 down here. Now, in this case up here, the quote was the first. Interesting. But if we were to go lower on this list, again, you would get down to different colors of red. It progressively gets green is the highest percentage, and as you get closer to red, it's going to be a lower thing here. Let's generate this a whole bunch more times. We're back to twinkle, twinkle, bam. Now we had Mary had a little lamb. I don't know if you noticed that time, but the spacing that was in between that line, between the end of what I asked for and before this, again, the space in LLM words, a new line character is actually a token. So that's in there. This time it didn't consider I needed a new line. This is where I'm telling you again, output is not predictive. If you need it in a special format, you really need to tell it and explain what you want your output to look like. Now, in this case here, we'll go back. Well, Mary's down here. It is option number 2, but it does have a darker color than the green because it's a big difference between number 1 and number 2. Let's ask some other things like what? Oh, all of a sudden you go blank when you're on camera. Is the most healthy fruit? We might think that might be deterministic, but we'll see. Well, there are probably a lot of things that come back, and you can see here that it gave us a list. I spoke, well, I guess it put that in there. It must have. I wasn't really looking at the screen when I hit enter, so maybe my type ahead put that in for me. But it came back. Interesting thing here, it decided on a top 10 list, so of course the number 1 was going to be the highest percentage here. Other ways that it could have started the list would have been a dash, an equal, and some of these other options, which honestly, they're really weird, like blue. Maybe that was for blueberries, just like the dash B might have been a preface into what might be blueberries and avocados. Sometimes it's hard to tell, but for number 1, we got that. Interestingly enough, the number 1 fruit that it listed was not the most or the highest probability token it had. It really wanted to tell me about blue or some form of berries or maybe even apples, but it went all the way down to avocados. Now, after it chose the AV, which was red, avocados, or is O, yeah, avocado, well, that naturally follows what might preface AV in the context of fruits. Now, if I had asked it a question about television or maybe videos, AV might have been followed by a space, because AV is a common phrase in videos and technology. So it might be the AV popular or the AV technology, etc. So this second token here even is referential earlier in the statement. These are all things that you'll learn in computer programming and stuff when you go. You don't have to worry about it. I don't want you to feel so confused. Again, the nature of this video is to help you understand what generative means in API. So generative does not always give you the highest probability, and then when it moves from one token to the next, it considers things earlier in the chain to determine the value of this next token. It has more insight than the last token it gave you. Why is that important? In the context video that I shared the other day, context is the size of everything that the LLM can remember with you in conversation. Sometimes it's really small. When you get on your cell phone and devices, this could even be down around 512 or 1,000 tokens, which is a very short conversation. If you're reviewing a book with multiple chapters, you might get up to 32,000, or even the Google, the Gemini Pro, that's a context window of 2 million. Those things can all lend themselves to the probability or predictiveness of the next token in generative AI. Now, you might be thinking, well, how do all these tokens work when I'm dealing with things like image generation, like DALL-E or Midjourney? At the heart of all of this, before any of those generations take place, everything breaks down in tokens. We're dealing with text now because you and I talk in words, and so text tokenization makes the most sense to us. When you think about images on the screen, if you understand pixels and colors, then you can kind of get an idea of what tokenization of colors would be. The computer doesn't represent the word avocados or some here in the words of text. It creates an array of numbers for that. So the word sum would be broken down into something called a vector. I haven't shown you that or discussed it much, but it's typically a series of a lot of numbers with decimal point precision. In computers, we call it floating point. The most common term for our generations is that the number of variables in that tokenization are right around 1,500 different number combinations assigned to every individual token, but it can get much higher than that. Well, in the case of colors, if you're familiar with RGB colors, like whenever you've dealt with a graphics artist, they'll ask you for maybe even a hex color. The hex color for white is a series of 6 Fs in a row. When that translates to a computer, those numbers break down to the number 255 in RGB. 255 has something to do with decimal and binary. Again, super nerd stuff. Don't worry about that. But the result is, even though we translate and see text, to the computer, it's numbers. Colors, images, shape. To the computer, it's numbers. And every number gets assigned a probability. And the probability is based on whatever is in the context window. Things that I just answered right here, like avocado, have a higher likelihood of affecting the next token than something that was added much earlier in the context. That's why even though having a context window of, say, 2 million tokens may not always be as helpful as you think it is, because as you go back in the context window, it affects the likelihood or probability of this next token. That's very much what's happening down here with both the frequency and presence penalty. It takes the value of the next token and then modifies it either based on a setting you said or the context in the prior window. That's a lot of me talking. I'm sorry. I hope this helps. Play around with this. Again, this is at platform.openai.com. Come down to completions. Again, they don't offer this functionality with the chat model. And play around with it. Change these sliders and you'll begin to see stuff that I was talking about. I told you earlier that when you put the temperature really high, what does it come up with? Let me regenerate this. It won't take many. Bam! All of a sudden, you've just gone off the rails here. Now, I want to show you something here. You just see how this keeps going and going and going because you freak out? This is the maximum length of the response tokens. My window might be 2 million character tokens long, but whenever I ask AI for an answer, it's almost always bounded by a maximum token length. So if you come down here, it responded, well, in this case here, I don't know why, it responded with 1,200 tokens, 1,291 out of the potential 2,000. It could have gone up to 2,000, but it didn't. Now, if I take this down to, let's just say I want 100 tokens, and then I regenerate this, I'll probably get a nonsensical answer again, but it's going to stop again at the 100 token mark. I know I told you I was done, but sorry. You'll notice again that these don't have colors. The reason is because almost every color is a 0% word, which tells you the answers are going to suck. Thanks for your time. If you like this, please like and subscribe. It helps the channel. It lets me know if any of this stuff really is a value to me or value to you, or if it's just an issue of me kind of listening to the sound of my own voice. I hope it's not that way. Thanks. Talk to you later.